Welcome everyone. In this video, we will be deriving one of the most famous equations of all maths, at least basic maths. So what we will be deriving is the quadratic formula. Okay? So the quadratic formula tells us that if we have a quadratic equation, which means we have an x squared term, if we have something like this, and this is equal to 0. This is the general form of a quadratic equation. So the formula tells us that if we have this equation, we can find its solutions. We can find the roots of it. We can find two values for x. And those values will be equal to negative b plus or minus the square root of the quantity b squared minus 4ac all divided by 2a. This is what the formula tells us. So in our goal in this video is to show that this formula is indeed true. How can we do this? Well, let me first get rid of the formula. We will arrive at it at the end anyway. Here we go. So what I do is, I first of all divide both sides of our equation by a. So I divide both sides by a. Now let me erase this part as well. Okay. A heads up here, you might be saying, hold on, are you sure you can do this? Maybe a is equal to 0. In that case, you can't divide by 0. Well, you are right. But we know that a is not equal to 0. Otherwise, we wouldn't have a quadratic, right? If a is equal to 0, the x squared term just goes to 0, and we have a linear equation which can easily be solved. So a is not equal to 0. Otherwise, as I said, we don't have a quadratic formula. I mean, we don't have a quadratic equation to start with. So we can divide by a. And when we do that, we have x squared plus b over ax plus c divided by a, and of course 0 divided by a is just 0. Now I want to subtract c divided by a from both sides. I subtract c over a from both sides so that we have x squared plus b over x times b over a times x is equal to negative c divided by a. What I want to do now is I will add, which might seem like a interesting choice. You might be wondering why I will do what I'm about to do, but I will explain it in a minute. I will add b squared divided by 4a squared to both sides. Now, where did this come from? This is a weird looking quantity. Why do I add this? Well, because if I add b squared divided by 4a squared to both sides, on the left side, I will have a square. Okay, when I add this, I can write it as this. This step is called completing the square. Completing the square. All right, to complete the square, you basically add the coefficient of x divided by 2 squared. So the coefficient of x is b over a. We divide it by 2, we have b divided by 2a, and we square it so that we have b squared divided by 4a squared. This completing the square rule is valid when the coefficient of x squared is 1. Which is why we divide both sides by a, to have the coefficient of x squared term just 1. All right? So we completed the square and we arrived at this equation, the quantity x plus b over 2a squared. This is equal to negative c divided by a plus b squared divided by 4a squared. Now we can make the denominator of negative c over a term 4a squared. So I multiply it with 4a. And what do I have when I do that? Well, this becomes 4a squared, and the numerator becomes negative 4ac. So since we have this, since we have the same denominator, we can add them. We can add them to arrive at this v squared minus 4ac. We are going great. So let me open a new page. What we have is this and this, I believe. Let's check if I am right. And yes, I am right. This is what we have. Now, what would you like to do from this? Well, let's take the square root of both sides. Let's do that. When we do this, we will have plus or minus x plus b over 2a. This will be equal to plus or minus b squared minus 4ac, and we can take 4a squared out of the square root as 2a. Of course, we have our plus or minus here. And we are coming to the end, my friends. So hang on. And what I want to do is I will subtract this part here from both sides. I will subtract it. When I do that, we have x is equal to negative b divided by 2a plus or minus b squared 4ac divided by 2a, which gives us negative b plus or minus b squared divided by 4ac. Well, hold on, why did I say divided by? Anyway, just focus on what I'm writing, not what I'm saying, okay? And this is it. We have derived the quadratic formula. A couple of things to notice from the formula is that the inside of the square root, the part where we have b squared minus 4ac, this is sometimes called the delta, the determinant, and what it determines is whether or not our quadratic equation has 1, 2, or 0 roots. Now, when does our equation have 0 root, 1 root, and 2 root respectively? 2 roots respectively. Well, for it to have not a root, for it to have not a real root, so let me say we have 0 roots. 0 roots means number of roots, let's say. 0 roots means that, actually, let's say number of real roots, right? We are working with real numbers. If we have 0 real roots, this means that delta is less than 0. Because if the inside of the square root is a negative number, well then we are not dealing with real numbers anymore, because in real numbers, inside of the square root cannot be negative. If we have 1 root, what does this mean? Well, this means that delta is equal to 0. The determinant is equal to 0. Because if this part is equal to 0, if this is equal to 0, well, then plus or minus 0, it doesn't matter. We get the same thing. We get the same thing, right? And in the case that we have 2 distinct roots, delta is just greater than 0, because if we, for example, if inside of the square root is 1, then this whole quantity becomes 1. Obviously, plus 1 and minus 1, they affect the value of our quantity. And one more thing before ending this video, how would you see these things graphically? Well, if you have a coordinate system like this with x and y, in case of having 0 roots, the graph would not touch the horizontal axis. This means delta is less than 0. If you have 1 root, the graph would be tangent to the x-axis. So, for example, you would have something like this. This is tangent. It intersects the x-axis only at one point. This point is sometimes called a double root. And this is in case where the determinant is equal to 0. And when you have two roots, obviously you can guess it. Well, then we have two intersection points with the x-axis. And this happens when the determinant is greater than 0. I hope that you enjoyed this video. This was a quick derivation of the famous quadratic formula. Afterwards, I tried to explain how we can interpret some information about our equation using the formula, and I did some graphical drawings as well. I did some analysis from the graphs. I hope that you enjoyed this video. If you have any comments or suggestions, please do not hesitate to write them in the comment section below. I hope to see you in another video. Until then, take care.